Section 5.2, writing linear equations given the slope and a point. So today we're still going to be writing linear equations. It's going to be very similar to the last lesson, but the difference is the type of information that we're given. So today we'll be given a slope and we'll be given a point. And sometimes this is very readily apparent. It's easy to see. Other times you're going to have to work for it a little bit. Okay? Feel free to pause this and come back and read it whenever you need to. But here's basically what we're going to be doing. Okay? So in order to write a linear equation, we can do this if we are given the slope and if we are somehow given a point. And by point, I mean x comma y. All right? The first thing we're going to do is we're going to find the y-intercept. Remember, the y-intercept is the b value. Okay? So we're not being given that today. We're going to have to work for it. Okay? So to find the y-intercept, you're going to substitute the slope and the coordinates of the point into the slope-intercept form. So basically, we're going to know the slope. We're going to be able to plug in the x and the y from the point. And if you notice, there are 4 variables up here. We're going to know 3 of them. We'll be able to work backwards to figure out the 4th one. And that 4th variable is the b, and that's the y-intercept. So we should be able to plug in what we know to figure out what we don't know. Okay? Once we figure out this, the y-intercept, we'll have everything we need. Okay? We can write an equation for the line when we know the slope and when we know the y-intercept. And then we'll just write the equation in the form y equals mx plus b. Okay? So we're building off of things that are already kind of familiar to us. All right, so let's do this one together. I do want you to write this down, even though it's not a blue example. We're going to go through a couple different practice problems, and it's going to be good for you to write this down as we go through. It's going to help you when you have to do them on your own. So it says, write an equation of the line that passes through the point -3, 0, and which has a slope of 1/3. So notice they have directly given us a point, an x comma y, and they've directly given us a slope 1/3. So where do we begin? Well, we're going to begin with slope-intercept form. So go ahead and write down y equals mx plus b on your paper. Where do we go from here? Well, let's write in what we know. Okay, we know what the slope is. The slope is going to be 1/3. So we start off maybe writing y equals 1/3 x, but we don't know what that b value is. We don't know what our y-intercept is. Okay. But the other piece of information, remember, is that we do have an x-coordinate and a y-coordinate here. So we have a specific point that happens to be on this line. Well, we can plug in those values. We can plug in the -3 for x, and we can plug in the 0 for y. So let's go ahead and try doing that. So for the y, it gets a 0. So 0 equals 1/3, and then we're going to plug in -3 for x. How we filled in our knowledge, right? This is definitely solvable. Okay, so 0 equals 1/3 times -3 plus b. And here you just have to be fluent with your fractions, right? So if you need to do a little side work, 1/3 times -3 is going to be the same as 1/3 times -3 over 1. And you remember that's top times top, bottom times bottom. You get -3 over 3, which is just a fancy way of saying -1. Okay, so 0 equals -1 plus b. Don't stop there, right? You still want to work this out algebraically. To get b by itself, what do you need to do? Well, you need to add 1 to both sides. And then you get 1 equals b. Remember, that's not your final answer. That's just your b value. That's your y-intercept. Okay, once you know a slope and a y-intercept, you can write the equation. So final answer here, the equation is y equals, insert your slope, 1/3 x, and then insert your y-intercept, plus 1. Slope-intercept form. And that is that's the most simplified version of what you're going to be doing in this lesson. They don't always directly give you these 2 pieces of information. Sometimes you might have to think your way through maybe a word problem, something in context, or something that maybe looks like this. So just remember, 2 lines are parallel if and only if they have the same slope. So here we're dealing with parallel lines. Okay, so here's another example. I want you to write this one down with me. It says, write the equation of the line that is parallel to the line y equals negative 3x minus 2, in which goes through the point 3, comma, negative 4. So I want you to think about what that means for a second. The line that we are interested in is not y equals negative 3x minus 2, but it's parallel to that line. And so if our line is parallel to that line, what's going to be the slope of our line? Well, if they're parallel, they're going to have the same slope. Okay, so the slope of our line is going to be negative 3. Because remember, parallel lines will have the same slope. So when you see the m value here, if that line has a slope of negative 3, our line is going to have a slope of negative 3. So we already have our slope, we just don't have our y-intercept. But they did give us a point. They said that it passed through 3, comma, negative 4. So let's go ahead and write down what we know. Always begin with y equals mx plus b. They told us the slope in kind of a roundabout fashion, but it's going to be parallel to that line, so our slope is going to be negative 3. We just don't know what that b value is. But remember, they did give us a point. We can plug in 3 for x, and we can plug in negative 4 for y. So that would be your next step. Negative 4 equals negative 3 times 3 for that x plus b. So of the four unknowns, we know 3 of them. We can work backwards to figure out that b value. Negative 3 times 3 is going to be negative 9. So negative 4 equals negative 9 plus b. Don't stop there. Add 9 to both sides. And it looks like your b value equals 5. So final equation, let's put everything together. We know that the slope is negative 3, and the y-intercept is at positive 5. So y equals negative 3x plus 5. Okay, let's look at one more. Okay, here we have a word problem. It says at the start of your second year as a veterinary technician, you receive a raise of $750. You expect the same raise every year. Your total yearly salary after your first raise is $18,000. Okay, so somehow we're going to use this information to do a couple different things. We want to write a model. Okay, write an equation that models your yearly salary S in terms of years in since you started. And then we'll move on to B once we get that model. Okay, it says calculate your yearly salary after 6 years as a vet tech. Well, let's not worry about B yet. Let's try to come up with this model. All right, let's go back to the situation. If we want to write a model, we should be able to find a slope and a point in here. So kind of read this again. Of all those numbers they throw at us, which one might function as a slope? Well, it says you expect the same raise every year. So every year it's going up by the same amount. What is that amount? $750. So this would be like our slope. You go over 1 year, you go up $750. Over 1 year, up $750. All right, that's a slope. Okay, 750 over 1. What about the point? Well, for the point, it says that your first raise, so after your first year, okay, your salary went up to $18,000. So that's not your starting amount. That's not your y-intercept. But it is where you landed after your first year. So that would function like a point. Maybe after 1 year, it's $18,000. So that could be like 1 comma $18,000. All right, so let's write this information in. You might just want to jot it down on your paper. The slope would be like the $750 per year. The point would be like 1 comma 18,000. After 1 year, $18,000. All right, so using this information, we're going to go through the same process to come up with a model. Okay, so let's begin with y equals mx plus b. Go ahead and write that down with me. You know what your slope is. It's that 750. you do have a point. Okay, that x value is 1 for 1 year. That y value is 18,000 as the output. Okay, so I'm going to write in that 18,000 as my y, and that's going to equal 750 times 1 for x, tacked on to b plus b. And we know that 750 times 1 is 750. And then we just need to take away 750 from both sides. And essentially all we're doing is saying, hey, he's only worked for 1 year. If he had a raise of $750, you're just subtracting that 750 from the 18,000 to see, oh, where did he start out? Okay, well, he started out at 17,250. That is his y-intercept. That is his b. Remember, the y-intercept is the starting amount. Okay, so you have a slope. You have a y-intercept. Let's put it all together. Okay, so therefore, you could have y equals 750x plus $17,250. And I didn't really do that correctly according to the problem. If you go back up and read part A, it says write an equation that models your yearly salary S in terms of years in. So I want to use the variables S and N. Okay? Which one would be the input and which one would be the output? Well, years would be the input and salary would be the output. So we want to change this to maybe S equals 750N plus 17,250. That would be a correct model. Okay, now let's use the model. So B says calculate your yearly salary after 6 years. So what would you do? Where would you plug in that 6? Well, you'd plug in that 6 for the N. And you might want some calculator assistance here. But when you do that 750 times 6, I believe you're going to get 4,500. And you're going to tack that on to your original starting salary of 17,250. So after 6 years, your current salary would be $21,750. Okay? Following the same method as before, just doing it with slightly more real-world numbers. Okay, so that's it for me. Now it's on you. Let's see how you can do on your own. Okay, so here are your blue examples, starting with 1. We'll kind of go back to an easier one. It says write an equation for the line that passes through the point 2, 5, and which has a slope of 4. Okay, go ahead and do this on your own now. Hit pause, and then don't unpause until you're ready to resume the video and check answers. Okay, good luck. Go ahead and hit pause now. Okay, let's take a look at how you did. So hopefully you began with y equals mx plus b. It's always a good place to start, even if you're kind of confused. You know that it's going to need to fit this slope-intercept form. And then start plugging in what you know. Okay, so for example, I know that my slope is 4. I know that my x-coordinate is 2. And I know that my y-coordinate is 5. Notice I plugged in that x inside parentheses just because it's multiplying the 4. I didn't feel the urgency to use parentheses over here just because it's by itself. Of course, I could put it in parentheses, but there's nothing to really protect it from. Okay, so don't forget the plus b. That's what you're trying to figure out. You're trying to figure out that y-intercept. Okay, so 5 equals, 4 times 2 is 8, so 5 equals 8 plus b. To get b by itself, you would take away 8 from both sides. And when you do that, it looks like you get -3 for b. So that means on the graph, the y-intercept is going to be at -3. The graph will cross the y-axis at -3. So let's write our equation. Slope was 4, so y equals 4x, and then y-intercept is negative 3, so 4x minus 3. Hopefully you got that one right. If not, if you're still having trouble, be prepared to bring those questions with you to class tomorrow. Let's try another one. Okay, example 2, write an equation for the line that is parallel to the line y equals negative 2x minus 1, and which goes to the point 4 comma negative 1. If you need to rewind the video and kind of look back on the one that was similar to this, feel free to. But remember, you're looking for a slope, and you're going to use the point that's given to you. Okay, good luck. Try this one on your own. Unpause when you're ready to go over answers. Okay, remember, our line is not the same as this line, but it is parallel to this line. The y-intercepts are going to be different, so don't think that negative 1 is going to be our y-intercept. It'll be a different y-intercept, but what is the same is the slope. So this is where we're getting our slope from. Our slope is going to also be negative 2 because parallel lines have the same slope. Okay, so I can begin with y equals mx plus b. I know that our slope is negative 2. And then I can also plug in the x-coordinate and y-coordinate for x and y. So the y value of that ordered pair was negative 1. And the x value was positive 4. And then I just need to do some basic algebra from here. So negative 2 times 4 is negative 8. Negative 1 equals negative 8 plus b. A common mistake is that people will get lazy. They'll stop here. They'll look at negative 1. They'll look at negative 8 and say, ooh, it should be negative 9. Okay, don't do that. Always follow through to the end. You have to get b by itself. To get b by itself, you need to add 8 to both sides. You'll see that when you add 8 to both sides, you're not going to end up with negative 9. Negative 1 plus 8 is a war problem. Positives win. They win by 7. So your b value is a positive 7. Okay, let's go ahead and put that all together. So final equation should be y equals negative 2x plus 7. Okay, hopefully you are 2 for 2 at this point. Let's see if you can now apply it to a word problem. Okay, so Mr. Karpinski, who was my former math teacher, freshman and sophomore year. I kind of lied about the years here, but Mr. Karpinski started teaching in 2009. Each year he receives a raise of $1,200. In 2012, he earned $29,600. Okay, so use this information to come up with your model in part 1. So write an equation that models Mr. Karpinski's salary S in terms of years T since he started. Okay, and then once you have a good working model, something that you're satisfied with, use your model to do number 2. What would Mr. Karpinski's salary in 2016 be, or what would be Mr. Karpinski's salary in 2016 according to the model? Okay, try to do this one all the way on your own. Don't cheat. Don't unpause until you're really ready to go. Work your way through it. It's going to be very similar to the one we did before, but not exactly the same. All right, good luck. Unpause when you're ready to go over answers. All right, let's see how we did. So first thing we have to do is come up with that model. Okay, so hopefully you were able to identify the slope. The slope is going to be the $1,200 per year. Remember, slope is a rate of change, so his salary is going to change by $1,200 per year. Okay. Now, the $29,600, that's not our B, because that wasn't his starting salary. He started back in 2009. 2012 is obviously, 3 years removed from that. But the number 3 is important. If you subtract 2009 from 2012, 3 years have passed since he did start. Okay, that's going to help you come up with your point. The point here is going to be in his 3rd year. So 3 comma, he earned $29,600. That should be the point that you are using. Okay, so using that information, let's go ahead and see if we can come up with our model. All right, y equals mx plus b. Okay, we know that the slope is going to be $1,200, so $1,200 per year, plus whatever his starting salary was. We're not sure what that is yet. Let's go ahead and plug in our point. So for his third year, it was $29,600. The input is 3. The output is $29,600. So I'm going to put my y coordinate, my output, over here for y. And my input, my x value, 3, and here for x. Okay, so basically he's had 3 years of raises. That's $3,600 worth of raises. And essentially what we're doing is we're going back in time 3 years. So we're going to take away that $3,600 of raises to see what his starting salary was. Right? And when we do that, we end up figuring out that his starting salary was $26,000. That's your B value. Okay, we're not done, but that's our B value. So if we want to write this in slope-intercept form, we'd say y equals 1,200 x plus the starting value, the y-intercept, 26,000. But they didn't ask us to use x and y. They did say write an equation models Mr. Karpinski's salary S. So instead of y for output, we want salary S equals 1,200 times the number of years T. So it told us to use a T plus 2,600, or sorry, 26,000. That would be your model. Base salary right there, and then every year, T, every year, we're going to tack on $1,200. Okay? So hopefully you got the model right. Let's take a look at number 2. Number 2 says, what would Mr. Karpinski's salary in 2016 be according to the model? Okay, well, how do you know what number to plug in? I might start writing down my model again. S equals 1,200. But what's the T value going to be? I mean, are you going to plug in 2016 right here inside the parentheses? No. What number would you plug in? Hopefully you said 7, because we're going all the way back to year 1, 2009. The difference between 2016 and 2009 is 7 years. So it's been 7 years since he started. That's the number you want to plug in. 7 years of raises. Okay, that's why we're multiplying the 1,200 times the 7. Tack that on to the starting salary. Okay, and when you go ahead and just crunch the numbers here, the raises multiply to 8,400. So 8,400 worth of raises tacked on to an original salary of 26,000. And that's going to give you a salary in 2016 of $34,400. Okay, hopefully that made sense. Good luck with the assignment, and obviously if there are any questions, please bring them with you to class. You can ask me or you can ask your group mates. Good job with this. All right, see you soon.